سڵاو قوتابیان خوێندکارانی عزیز لەوانەیە دووەم لە چاپتەری سێ دەست دەکەم بە تەواوکردنی بابەتی pH لەسەر بنچینەکانی هایدرۆنیوم و هایدرۆکساید. Okay, let's start. In a prior lecture, I have talked about hydronium and hydroxide and so deeply, and I'll give you more details about them even today. Well, calculating H3O and OH in aqueous solution of strong acid and strong base. Remember, this time we are going to deal with strong acid and strong bases only. That's why there are no chance except of memorizing acid and base, the strong one, okay? The strong acid and strong base must be memorized already, but okay, I'll help you to remember. Strong acids. We have HIH, Br, HCl, HClO3, ClO4, well, HNO3. Forget about chromic acid. Okay, forget about chromic acid. I'm sorry that I included in my table. And strong bases, you know, group 1, alkaline metals, and group 2, only calcium, barium, strontium are producing strong base. When they dissolve in water, they react by a single displacement process reaction. They substitute the hydrogen of water to producing strong base. Well, strong acids are molecular, and this one is ionic compound. Strong base is ionic compound. So these are ionic compounds. They dissociate completely, and they are ionized completely due to their weak bond. The weak bond presents between hydrogen and anion, but here because of their strong polarity and weak bond between cation and anion, so they dissociate in water completely. Well, so this time we are going to calculate H3O and OH, but according to the concentration. Did you remember last lecture I have told you we can take out H3O using OH, or we can get the value of OH using H3O concentration. But this time, no. This time, we are going to calculate H3O based on the concentration of the acid, and OH according to the concentration of the base. Right? Well, we have these two formulas to get the value of H3O and OH. H3O is equal to number of hydrogen in the acid structure, or H3O in the ionization reaction of acid, and OH in the dissociation reaction of the base. Well, good. H3O equals to number of H. Well, I can simplify the equation like this. H3O equals to molarity times H in the acid's formula. OH equals to molarity times OH in the base formula. Well, these equations are applicable only for strong acid and bases. Okay. These are applicable only for strong acid and strong bases, because strong acids and strong bases, they ionize completely, so we know their degree of ionization. But about weak base and weak acids, actually we don't know how much they get ionized. So we are not sure about number of H and OH in the aqueous solution of weak acid and weak base. That's why they are applicable only for strong acids and strong base. If we have acid, there is no option except of calculating H3O by multiplication of molarity of acid times H. If we have base, okay, the first priority will be for OH, molarity times OH, number of OH in the basis formula. Okay. The equations of strong acid and strong base cannot be applicable for weak acids and weak base due to their slightly ionization, unknown extent of ionization. We don't know their degree of ionization. pH value of weak acid and weak base, they can be calculated practically based on the hydronium ion concentration. Okay. Now, let's solve some questions about aqueous solution of strong acids and strong bases. Well, let's see. Aqueous solution of HCl. HCl, it's strong acid. Well, so that means we have an aqueous solution of strong acid. So the only equation that is applicable that can make a relation between concentration and hydronium ion is equation of strong acid, H3O equals to molarity of the acid times number of H that present in the acid's formula. Well, this is molar concentration, a solution of HCl that has been prepared for the laboratory experiment, lab purpose. Okay, doesn't matter for any lab experiments. Well, calculate H3O and OH. Well, I'm going to make the question more tricky. That's why forget about H3O. Only get OH. It will be more tricky question. Well, okay, mister, we have acid. Look, we have molarity. Look, if you have gram, you can calculate number of mole. Okay? Then you can turn number of mole into molarity. Right? Then, when you get the value of molarity, look, when you saw yourself here, then you have to decide that your compound is acid or base. If it's acid, you have to calculate H3O. And if it's base, you have to calculate OH. Then you can make a conversion between them using Kw value. Well, and now we have molarity, we are here. So your compound is acid or base. HCl, it's acid. There's no option. You have to get H3O first step. So H3O equals to molarity of the acid times number of H that present in acid's formula. So molarity is 2 times 10 to negative 4 times H equals to 1. So molarity equals to 2 times 10 to negative 4. I mean molar concentration of H3O. H3O molar concentration. So now we get the value of H3O. But the question says OH. Mister, please, why you calculated H3O when we are looking for OH? Okay, because of your compound is acid, so there is no relation between acid and OH, acid molarity and OH, except of first you have to get H3O, then turn H3O into OH using Kw value. So OH equals to 1 times 10 to negative 40 divided by 2 times 10 to negative 4. So OH equals to 0.5 times 10 to negative 10, right? So it will be 5 times 10 to negative 11 molar. This is hydronium ion concentration. It's very easy. Well, another question. 0.5 liter solution of CaOH by 2 that has concentration of 5 times 10 to negative 5 mole. Okay, the compound is base and it's strong. So, mister, the first thing you have to get OH. Very good point. Determine the hydronium ion. Okay, look for the hydronium ion. Firstly, you have to calculate OH. Why OH? Because the compound is base. So for the base, we have to get OH. OH equals to molarity of base times number of OH in the base formula. So equals to molarity. Well, mister, we have mole. There's no molarity. Okay, you can calculate molarity here. Molarity equals to mole per liter equals to 5 times 10 to negative 5. It's number of mole. Divide by 0.5. So equals to, right, 1 times 10 to negative 4 molar. Right? So it's equal to 10. It's equal to 10. Divide by 10 to negative 5, it will be 10 to negative 4. So 1 times 10, this is molarity, 1 times 10 to negative 4 times OH. How many OH are present in CaOH value? In CaOH formula, CaOH by 2 is 2. So equals to 2 times 10 to negative 4 molar. This is OH. But still, we are not finished. We are looking for hydronium ion, so just turn this one into H3O. How we can get H3O value? Like this. H3O, 1 times 10 to negative 4, divide by 2 times 40, divide by 2 times 10 to negative 4. Okay, so it will be 0.5 times 10 to negative 10 equals to, right? 0.5 times 10 to negative 10 equals to 5 times 10 to negative 11 molar. It's H3O. Good? You know how it's easy? Piece of cake. Good. Another one. Let's solve the most difficult one. Well, 1 liter solution of 0.098 grams of sulfuric acid, H2SO4. Determine the hydronium and hydroxide ion concentration of a solution. The molar mass of H2SO4 is 98 grams per mole. Okay, I'll draw the flow chart to solving a question if we have gram. So what we're gonna do with the gram? We have to turn gram into mole. Okay, gram, mole. Then change mole into molarity. Then our compound is acid. So because of its acid, H2SO4, so we have to get H3O. Then we can get value of OH. Okay. Let's start. So first step will be changing gram into number of mole. Mole equals to, right, mass over molar mass equals to, well, mass is 0.098 divided by 98 equals to 0.01 mole. Then change number of mole into molarity. So we are looking to get the value of molarity. Molarity equals to equals to mole of solute per liter of solution equals to. Liter is 1, mole is 1 times 10 to negative 2. So it's equal to 1 times 10 to negative 2 molar. And then change molarity into hydronium ion using this formula. H3O equals to molarity of acid times number of H in the acid's formula equals to 1 times 10 to negative 2 times 2. Why 2? Because of H2SO4 contains 2 protons. Well, equals to 2 times 10 to negative 2 molar. It's H3O. And then change H3O into OH using KW formula. So KW equals to OH times H3O. Then if we calculate OH, it will be 1 times 10 to negative 40 over 2 times 10 to negative 2. It will be 0.5 times 10 to negative 12 and 5 times 10 to negative 30. Right, very good. So in this way, we can solve any question that are related to the relation between molarity and hydroxide, as well as hydronium also. Well, so first step, we just turn it mass into mole using this formula. So it's number of mole, right? It's number of mole. 0.01. Okay. Well, I'll change this. Now the question will be true. If it's like this, the question will be okay right now. Okay. I just changed this number. Now it's totally true. Okay, very well. 1 liter solution of that contains 0.098 grams of H2SO4. Determine the hydronium ion concentration. We have a solution that prepared by dissolving 0.098 grams of H2SO4. Determine the hydronium ion and hydroxide ion concentration. Well, hydronium and hydroxide ion concentration. How we can get hydronium and hydroxide ion concentration in this kind of question? Well, first of all, the given is gram. Unknown is hydroxide. So how we can get from gram into hydroxide? Look, we have gram, so we have changed gram into number of mole by mole formula. Mole equals to mass over molar mass. Then you can change mole into molarity. And after, because of H2SO4, it's acid, it's acidic, so there's no choice. You have to calculate H3O. Then turn H3O into OH value. Good. Now, we're going to change gram into number of mole. So first thing that must be calculated is mole. Mole equals to mass over molar mass. Equals to mass 0.098 divided by 98. It's equal to, it's 1. So 0.001 mole. Right? 0.001 mole. Now we have prepared number of mole. It's number of mole. Okay, very good. Number of mole must be changed into molarity. How? By this formula. Molarity equal to mole of solute divided by liter of solution. So equals to, mole is 0.001 divided by a liter, which is 1 liter. Okay, so molarity equals to 1 times 10 to negative 3 molar H2SO4. Now we have molarity, so it's very easy to get value of H3O. Okay, so H3O equals to molarity of acid times number of H in acid's formula. Very easy. Equals to molarity 1 times 10 to negative 3 multiplied by H2SO4 contains 2 protons. We have 2 protons here, so multiply by 2. It will be 2 times 10 to negative 3 molar of H3O. Very good. Now we have molarity of H3O. Then we can change H3O into OH concentration. Let me focus on the pointers. This is molarity, and this is H3O. And then we are looking to get value of OH, hydroxide. So according to Kw value, OH times H3O, which is equal to 1 times 10 to negative 14. So now we are looking to get OH value equals to 1 times 10 to negative 40 divided by H3O. So OH value equals to 1 times 10 to negative 40 divided by 2 times 10 to negative 3 equals to 0.5 times 10 to negative 11 will be 5 times 10 to negative 12 molar. Of course, it's OH. Very easy. So in this way, you can solve any question. Just be careful about the strength of the electrolyte, because of just by changing 4 to 3, we must stop here. We can't go farther if we change this. Okay? And of course, these formulas are applicable even for weak, but this is only for strong, only for only for strong. But this one, they are only for these are only applicable. Actually they are applicable for weak and strong also, but this one only applicable for strong electrolytes due to their degree of ionization, which is known. Okay, let's see if we have another question. If not, we will go through the second factor, which is power of hydrogen, potential of hydrogen, pH. Well, I'll give you one more example here. Then actually I want to explain the pH in a different lecture separately. Well, look, we have question. Calculate OH concentration in aqueous solution of a base of, in aqueous solution of NaOH, okay, that prepared by dissolving okay, let me think about a number. Okay, 4 times 10 to negative 3 grams of NaOH, okay, by dissolving 4 times 10 to negative 3 grams of NaOH in 1 liter of solution. Very good. So calculate hydroxide ion concentration in the aqueous solution of NaOH that prepared by dissolving 4 times 10 to negative 3 grams of NaOH in 1 liter of solution. Well, we have gram, so we have to change number of grams into, okay, fortunately we have calculator here, a wonderful one, very good. Okay, maybe I need this. I need this, okay. So, firstly, we have to get number of mole. So, mole equals to mass over molar mass, right? Mass over molar mass. Mole equals to, mass is 4 times 10 to negative 3, right? Divide by, okay, molar mass of NaOH equals to 40 grams per mole. So divide by 40. So mole equals to, well, I don't want to make a mistake, that's why otherwise I know immediately to get the result 4 times 10 to negative 3 divide by 40. 1 times 10 to negative 4, okay. 1 times 10 to negative 4 molar, right? So it's sorry, mole, it's number of mole, right? So first step, I converted mass to number of mole. Then we have to change number of mole into molarity. So molarity equals to mole per liter, right? So molarity equals to, mole is 1 times 10 to negative 4, and molarity is, liter is 1 liter. So molarity equals to 1 times 10 to negative 4 molar. Okay, now we have calculated value of mole, then we change it mole into molarity, then because of our compound it's NaOH, so it's base. So for the base, strong base, we have to get OH as a first factor. So OH equals to, look, OH equals to molarity of base times number of OH in bases formula. So equals to, molarity is 1 times 10 to negative 4 times how many OH present in NaOH's formula? It's 1. So OH equals to 1 times 10 to negative 4. It's OH. But, okay? So what if we calculate H3O also at the same time? Well, H3O equals to 1 times 10 to negative 40 divided by 1 times 10 to negative 4, which is OH. This is OH. So it will be 1 times 10 to negative 10 molar. It's H3O. Okay? This is a concentration of hydronium and hydroxide in the aqueous solution of NaOH that made up by dissolving 4 times 10 to negative 3 grams of NaOH in 1 liter of solution. Well, I don't want to go farther. Actually, it will be one of my shortest lectures. Unfortunately, we have nothing more to study for today. Inshallah, in next lecture, I'll start by pH value. Then we will finish section 1 and we'll start by section 2 next week, inshallah. تا وكات بخواتان دسبيرم هشاو سرفراز من خواتان لقل